Power. Power is the rate at which work is done, or the rate of doing work. We could define that either with that statement I've just written down, or we could define it with a formula effectively as being work done divided by time taken. So in simple form, power equals W over T, or since work done is equal to change in energy, you will sometimes see the formula also expressed as power equals E over T. And the SI units then are the watt, represented by capital W. Do not confuse capital W for watt with capital W being the symbol for work. Okay, so you need to just be a bit careful there. So a watt is equal to a joule per second. All right, another formula for power. If you've got a force being applied to keep something moving at a constant velocity because you're overcoming opposing forces such as friction, then power P we know is work done divided by time taken. But work from our general formula for work done by a force is force times displacement divided by time. And we know that S over T, or change in displacement over time taken, is the same as velocity. So we end up with a formula being power equals force times velocity. So that's a formula you need to know. That's a formula you need also to be able to derive. In other words, do what I've just done there to show that that is the formula. Let's have a look at an example of a calculation here. We've got a motor applying a force of 8,500 newtons to pull a cable along. And so we've got motion, we've got constant velocity, we've got a force acting. So if we want to figure out the power, then it is simply force times velocity. 8,500 times 4.8, and when we work that out, what do we get? 40,800 joules. And finally, in our topic, the idea of efficiency. Now, efficiency is all related to the fact that in real life, you always lose some energy somewhere because of heating, maybe in electrical cables, or because of frictional effects or viscosity or whatever. You never can get out what you put into a system. So efficiency could be the ratio of the energy out divided by the energy in. Energy out on the top line always being smaller than energy in on the bottom line. And if we want it expressed as a percentage, we could multiply by 100. We could also express efficiency using power, because power is simply the rate at which energy is coming out or going into a system. So power out divided by power in times 100. And let's just finish by looking at a brief example. A crane doing 80,000 joules of work, raising a 200 kilogram mass through a vertical height of 25 meters. We want to calculate the efficiency. So let's first of all figure out the work, not the work done, the gain in gravitational potential energy, because that's going to be less than the amount of work that is done. So we've got 200 kg times 9.81 for G times 25 meters. And so the amount of, or the gain in in potential energy is 49,050, which is less than our 80,000 joules. So the efficiency, or the percentage efficiency, would be the ratio of 49,050 divided by the energy that has been put into the system, 80,000, and let's just multiply that by 100 to turn what would be simply a decimal value into a percentage value, and we get 61.3%.